Hey guys, I'm going to talk about odd and even functions, but to start with I'm going to talk about faces to help you remember it. If I told you that I saw a person with really even features, what you would expect is that if you split their face down the middle, that it would be very symmetrical. Remember that even means divides nicely into two. If I said to you, oh, that person was pulling an odd face or had an odd expression, you'd be like, odd expressions always look a bit skew-if. In maths, it's a little bit more technical than that, but not actually that much, not that different. Here we go. And here are some odd, even, and neither functions. As you can see, the even functions split down the middle and are symmetrical either side, just like the face. The odd functions are actually symmetrical, but in a different way. What happens is you have a rotational symmetry that if I took this piece and rotated it 180 degrees, it would go down there. So it's not a line of symmetry, it's a rotational symmetry that we're creating here. You could also consider it as I could flip it across this axis, which would put this piece here and that piece there. So flip it one way, and then I look at the other axis and flip it again, and then I get back to where I started. But I think when you're looking at it, it's much easier to see it as rotational symmetry. The neither functions, of course, there's no symmetry to it, but I would like to point out this one down here is the same as this function, but moved over, because it's only the symmetry across the y-axis that matters. And since it's not symmetrical in that version, it's not considered an even function. In practice, if you were asked, is this function odd, even, or neither, and you didn't know what it looked like, all you would have to do is find the function of negative x. When we do this, we literally replace the x with negative x, and then we go, how could I get rid of those brackets? Well, if I square a negative, it becomes positive, and if I square x, I just get x squared, so that's that. Since that is f of x, I've got f of negative x equaling f of x, the function is even. Here, if I try the negative of x trick, negative x cubed equals the negative of x cubed, because a negative times a negative is positive, times a negative again, which is required for cubing, makes it negative, which is the negative of my original function, therefore odd. If I have something like f of x equals one of those ones that didn't go odd or even, I actually can't simplify the square root of negative x. I can't do anything with that. It literally takes the square root x function from that, turns it into that. There's no algebra simplification. It doesn't equal f of x or the negative f of x. It just equals that. Therefore, neither. You can do more complex ones as well. Again, just substitute in the negative of x where x goes every single time x appears. Then simplify it out as we did before, and then see if it's the original function or not. Here are another couple examples just to show some extra features. This time I put the negative x on each part, I simplify them out, and when I'm done I can see I don't have the original, but if I factorise that minus out, remember the minus that appears in front of the x squared now does make it the original, with a negative out the front making it odd. In the last example, I'm taking the same equation, but I'm putting a +1 at the end, which will then, as you see what comes up next, I plug it in, get rid of the brackets, and it doesn't equal the original because of the plus and the minus in the wrong spot. Factorise the minus, it still doesn't equal the original, making it a neither odd nor even. Now it's your turn. Pause the video and have a go. The answers will pop up in a sec. Okay, so the first one came out even when I simplified it. The second one came out neither, because even after putting the negative in, it doesn't look like the original. If I factorise it out, still doesn't look like the original. This one I've got cos x or cos of negative x. Now, if you don't know the rule, the best thing for you to do here would be to sketch the cos function. And then go, okay, that's cos x. Cos of neg x would actually flip the x-axis, making it symmetrical. Even. This one here as well, you can probably tell straight away that there's no way I can invent that negative back in the middle once it's gone. So this one's neither. out of curiosity, if I were to sketch it, the square root of 1 plus x would be a function that goes like this, and the square root of 1 minus x would be the function that goes like that. So yeah, definitely not.